Hot chocolate, Azure Cosmos,
Entity framework, power tools,
NET Suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shai Rojansky.
Grace Lanston.
Martha Vickers.
.NET Data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Awesome. So we are live again. Welcome, everybody. It's April already, so that means it's the 4th stream of this year. And today we will be talking about how we are actually testing EF Core, what we do, how it maybe differs from testing your application, and all of the around. As you can see, it's only me and Maurycy here at the moment. Shai is having an important meeting, so he will be joining us a little bit later. And Maurycy is actually our expert in testing. So once we start talking, he will be correcting me or Shai with our incorrect assumptions about our testing and whatnot. But before we jump into the talking, we obviously need to do a little bit of housekeeping and tell you a little bit about what's going on with EF and what you can do with these previews. So EF Core 10 is now in preview 3 mode. So if you go to NuGet or whatever place you are downloading these like latest bits, you can get the preview 3, you can test it, you can play with it, and you can give us feedback on the new features. If you search for EF Core 10 preview 3, you will find the release notes on the GitHub, but I will give you a little bit of the summary. So let me actually put it on screen. This should be it. And yes, there it is. So I have here my window. As I said, well, maybe you can find it with the URL or just find it using your favorite search engine. So preview 3 is out. It's been quite a while that's been out. It's not like today or anything like that. And we have one feature that spans the Azure Cosmos DB. So to give you the summary, basically in previous versions of EF Core, when you connect it to the Azure Cosmos DB and you started adding properties, actually required properties into your classes, into your entities, then you have the problem of fetching the previous ones, because the previous ones in the database, they were missing these properties, and because these were required, the EF Core was throwing an exception. So you had to do some dance to actually add those into that one, and then you were able to fetch it. So that was a little bit painful, and the story was not super like polished and everything. That's no longer the case. Now you can go and just add required properties and fetch them. And if you don't have those properties in there, you will get the default values. So it's absolutely fine. We'll not throw an exception or anything like that. We have also a few small improvements. The first one is for the logging. So if you use some kind of logging, either to console or some other pieces, you know that we are logging the SQL query. And in some situations, we are inlining constants. And these constants, similar to parameter values, can contain some sensitive values, like email address or a name, or I don't know what not. So by default, we are, at least for parameters, not printing the values because they can be sensitive. Now, even for these inline constants, if you do not have the sensitive logging on, you will just see question marks. The same way for parameters. If you enable the sensitive logging, then you will see the values the same way with the parameters. Similarly, for the SQLite, there was a contribution that improved the load extensions. So if you deploy your applications and you have your extensions in I don't want to say different places, but in like expected places, but different names, and there's a lib prefix and so on, it was not loading it correctly. You had to specify it exactly. So it was a little bit of the dance to deploy the application correctly. Now, as long as it fits the standard setup with like lib something.so and everything, it will load it. So you have less hassle of fiddling with this one. So that is the preview 3. And let's jump into talking about the testing in EF Core. So
yeah, I can start. So hi guys, my name is Maurycy. I'm one of the engineers on the EF team, and yeah, we will be talking about the testing, how we approach the testing of the EF Core. It's probably mostly going to be useful for people who want to contribute to the project, but maybe some of the learnings that are more applicable to general programming. So our basic approach is, we think testing is very, very important. We put a lot of effort into maintaining our tests, adding more tests. We have constantly adding more tests. There's never enough tests. At the moment, we have about 135,000 tests total. 50,000 of those are targeting SQL Server. This is our most tested provider. And those are the tests that are end-to-end. Basically, all of the 50,000 are end-to-end tests. Like, for instance, the query test that we do, they would create a database, they will send it, populate with data, send the query, verify the results. So some of the learnings that are kind of apparent from the beginning is we are okay. So basically, there is it's not too scary to test against the live database. For instance, many people that we've noticed, they are kind of apprehensive. They try to test against the in-memory, for instance. But the problem with that is that it doesn't exactly test what your production is doing. And we discovered that having a 50,000 functional tests, those are functional tests, we actually can run the tests quite quickly. So I checked yesterday on my machine, which is about 6 years old. It all ran in about 8 minutes. Mm-hmm. We had a demo the other day by Arthur, who had the Threadripper with 64 cores, and I think he ran all the tests in about a minute and a half. So we encourage you to try to test against the live database if you haven't, and you might be surprised how good it is. Maybe it's not, but your mileage may vary, of course.
Okay, I will
Mhm.
play kind of a devil's advocate here.
Okay.
So we do test against the live databases, but some tests, or let's say most of the tests, are doing just the translation, right? So would it work if we would just test that the SQL is what we expect it to be and just forget about it, not fetching the data? Would that work?
Well, I mean, no, we definitely want to test the data. We want to test the results. That is one of the most important things that we do. We, the data corruption issues are something that we want to avoid. Like, we don't want people's money disappearing from the bank accounts, for instance, right? So definitely just looking at the more closer to the method you kind of get, the better.
Yeah.
So that's
So can
how
you
I-
maybe explain what the data corruption issue actually is?
Sure. Yeah, the data
For
corruption
people that
is
don't know it?
yeah, it's the bug that we would have where the data that we give you is not what we're supposed to give. So let's say that there is some translation failure and we either don't return all the results or we would just corrupt the values of some floats or whatever. That would
Yeah.
the devastating part of it is that your live data and there are some important information that people are actually
Right.
processing with entity framework, and if those things start disappearing, then who knows
Yeah.
what's happening, right? So that's why
to
we
give
have a huge emphasis on that, and we want every single query test to verify the data. That is our approach.
awesome. To give a little bit of the context to the viewers, when entity framework is processing the query, it goes basically through a few distinct stages. First, we obviously translate the query from the link that you provided into the SQL. It goes through small steps in this one as well, but that's not important. We basically take the link query and we translate it to SQL. But as part of this translation, we also generate something that we call shaper. And the shaper is responsible for basically reading the data from the underlying data reader. And maybe you can correct me if I'm not saying it exactly correctly, because Maurycy is actually working or focusing on the shaper as well. And if we make a mistake in the translation, obviously we would see, hey, the SQL is incorrect or something like that. But we can make a mistake in the shaper as well. And then we will be fetching like wrong values. We might be fetching only half of the string, or part of the JSON is missing, or even we might hard code a constant somewhere. So instead of fetching the ID of the record, we might be fetching constantly 1, which is something that you would maybe not spot immediately, especially if it's like, hey, it's missing some white spaces or something. But definitely when you fetch something, then you do some transformation, like you change the first name or last name of some person, and you save it back, and we lost in the meantime, I don't know, some characters and whatnot, then you would save incorrect data into the database. So this is something what we consider to be a data corruption. And although people usually think about data corruption when you are sending something into the database, the data corruption can happen even earlier when you are fetching the data, because you are already fetching an incorrect data. So when we do test, we actually need to go into the database, fetch it back, basically do end-to-end test. So you mentioned we have like 100-something thousand tests. Do you think that we have enough tests, or do we have too many, basically?
Well, so there's never enough tests, I would say. I mean, there is the query space is infinite, essentially. So there's always bugs lurking somewhere, but there is a diminishing returns problem, like with everything.
Right.
So the kind of little issue that we have is sometimes we have so many tests and they're spread around everywhere that sometimes we have testing same thing multiple times. So
Right.
there is definitely a problem with overabundance. But at the same time, because the tests, if the way that we structure them, they are relatively quick, then adding the test is not that much of a cost for the, it doesn't take that much time. So we don't mind. But yeah, definitely if you are making a PR, we will not accept it if you don't add tests for it. That is one thing that is a variant.
And it's sometimes a little bit painful, because you might be contributing a small feature, like really, I don't know, another overload for a method or something like that. But adding the test sometimes takes the same amount of time
or
than
more
implementing the feature, because you not only need to edit somewhere and like create infrastructure, but maybe you need to test the edge cases and everything. So yeah, definitely the testing is important part. And I don't think we've ever merged a feature without a test or anything
I
like that.
don't
Even
think so. Yeah,
even the simplest stuff around like data modeling and everything, or model building, we do have tests for
absolutely.
those.
I mean,
Yeah.
sometimes we have existing tests when you are changing translations. We can just
Yeah.
look at there's baseline changes, because we actually also are verifying the SQL that is being generated, and that sometimes is sufficient. But if there is some new translation, new capabilities, we always want tests. And then other thing that is worth mentioning is as I mentioned, most of our tests are functional end-to-end. We have very few unit tests. So for comparison with SQL Server, we have 50,000 functional tests and about 1,000 unit tests only. So we tried unit tests in the past. We didn't work that great for us. We used to actually use mocking frameworks as well. They didn't work that great for us as well. So this is one of the learnings that we had. The problem that we had there was a lot of configuration. You have like a one page of configuration to set up, test the one little thing. And then with amount of churn that we had in the code, those things had to be constantly modified. So it was just not scaling for us. And instead, we focus on the scenarios that are end-to-end customer. So this kind of captures what EF is supposed to do much better.
Right. Yeah. And it's fair to say that EF it's a library that is doing something from the beginning to the end. It's not like an algorithm that you can test or something like that. Because as I said, you send some data, you fetch some data, and so on and so on.
Yeah, we have some unit tests for like the low-level stuff that is very stable, but apart from that, we try to avoid them.
Okay, I will add my personal story, or at least, kind of a story. I don't want to say I hate that our tests take like 5 minutes on my machine. It's kind of still fine. But for the viewers, for the live viewers, maybe you can post into the chat, but that running tests for 5 minutes, and I mean the full test suite, not only a selected few, for 5 minutes, is it acceptable for you or is it not acceptable for you? Because some people have the threshold like, hey, if it's under 20 minutes, I'm fine, I will get a coffee or whatever, and then it's done. And somebody, that's me, if it takes like 2-3 minutes, it's like too long because I hate waiting. And sometimes I kind of lose the focus. And especially if it's on this, at least for me, if it's like 1 minute, 2 minutes, that's fine, because you do like, you basically breathe, right? And then you are done, you have the results, and you can do something else. If it's like 20-30 minutes, then it's also fine for me, because it's like, it's too long. I know I start the tests and I can do something else. Like, I don't know, I can do vacuuming, or I don't know, whatever, because you have 30 minutes to see the results. But if it's on the edge of like 5 minutes or something, it's like too short to do something useful in the office, around the house, or something like that. But it's still too long to sit and wait for it. So
we should add 5 more times more tests than we have. Is that what you're saying?
Maybe, yeah. We have one comment that says 5 minutes is a rookie numbers. 2 days is where the pain is.
Oh.
Yeah, I agree. Yeah, if you have tests that require two days to run, then I would be done.
For the most part, you don't run all the tests, right? You just run a really small subset of tests that you're working on currently, and only once you're done with the feature, at least you think you're done, that's when you run everything, right? So it's usually under that magical threshold. It should be like less than a minute in your usual development.
Right. Yeah. But sometimes, especially if I'm working on a feature in EF, I run like one test or a few tests, like manual in Visual Studio, and then you are not 100% sure that everything is fine, so you run the full test suite. It's like few and then full. And I see we have a Shai here, so let me put him on stage. Awesome.
Hello, and sorry for being so late.
You are excused. Not.
Thank you.
You need to bring me and Maurycy some cookies.
That will be difficult given our respective geographical locations in the world.
You know, there's something called shipping.
Ah, very interesting. Okay, let's negotiate offline.
No. Let's do it online so we have a proof that it happened.
All right.
So if we get 5 comments that say that you need to send us cookies,
Oh dear. Oh dear.
you need to do it.
I really should not have appeared late.
Well, that was your choice. So anyway, we were talking about how long is like painful and not painful for running the tests. And I said that for me, the 5 minutes on my machine that all our tests take is exactly the painful threshold, because if it's 1 minute or 2 minutes, I will wait for the results and do something. I don't know, like just check my phone and that's it. If it's 20 minutes or 30 minutes, I will go and do something useful in the office, around the house or something. But if it's 5 minutes, it's like too short to do something useful and too long to keep waiting for it. And somebody in the comments said that like 5 minutes is a rookie numbers, like 2 days is where the pain starts. So what's your take on this one?
Sorry, are you? Did you ask me or?
Yes.
Oh, I'm sorry. I'm just still kind of logging into everything. Can you repeat like super quickly? Now I'm with you 100%.
Are you?
I'll send you more cookies. I'm really sorry.
Yeah, see that? Like 15 million people heard that you will send more cookie. No, I was asking
Test
whether
running times.
test running times, whether like you have the 5 minutes, because we have like none of us has like a super great hardware that would run it in like minute or something like Arthur had. So is the 5 minutes, give or take, like painful for you, or is it okay for you? Like where is your threshold?
Yeah, so first of all, I don't necessarily run all the EF Core tests every single time. Like that's not necessarily the thing. I will generally run the tests that cover the thing that I'm working on, or maybe, for example, an area. Like if I'm working on the query pipeline in EF Core, I'll run the query tests, and that's already much less than all of the tests. But then like 5 minutes or even 10 is well below the threshold where things become, problematically long, for me at least. Like I've worked in projects where integration tests can take like, I don't know, half an hour even, or whatever. This is not that. Like it's very easy for me. Like when I'm kind of done with a PR and I want to be sure, I run the tests. Yes, I'll get up and make myself a cup of coffee, but by the time it's all over and I've looked at this or that, then the tests are over and it's all good. So for me, this is a very reasonable and in fact quite impressive kind of test running time, given the amount of coverage we're actually testing. Like those 5 minutes, they pack a punch in terms of like how much testing and how much confidence they give me in the change.
Okay. Good. So Maurycy, why our tests take only 5 minutes? What's the secret, given that we are doing end-to-end testing?
So there are a few secrets. I guess one thing is we parallelize quite substantially. So to that famous Arthur's computer with 64 cores, he was able to max it to 100% on every single core, for instance. So that's something that helps a lot. And also the way that we, at least I can speak to the query tests. So we have the two kind of ways that we do the query tests. One is the assert query, which is the main one that the bulk of our tests are using. And the trick that we use there is we actually just generate a database once, and then we run a bunch of queries with that one database. Generating the database is by far the most expensive part of the testing. So if you can, if you can cram a lot of tests into one test suite, then you actually are saving a huge amount of time. Shai?
Yeah, just add. So there's one implicit thing in what Maurycy said is that we take care to separate between the read-only tests, like the querying tests, and tests that actually change the database, right? So read-only tests are the easiest. You can set up the database once, and then you can parallelize the hell out of it. You can run as many read querying tests as you want. And in fact, for example, maybe Maurycy, you're going to show this later. A lot of our tests are based on the Northwind database. That's, by the way, problematic on its own, but we don't have to talk about that right now. basically, it's one database that we set up once when you run your, your tests, and then we have I don't even know how many tests, like from different test types, which all run in parallel, because that's what XUnit does. It runs test classes, tests from different classes in parallel, and all of them are hitting the same database. So you get the overhead, like Maurycy just said, the overhead of creating the database. You get it just once, and then you're just executing super fast queries. So what basically the message I'm trying to say is that we put in the thinking of separating the tests into the correct categories. Here's the read-only tests, and I've seen, like we see on our users, like on the repo, and I promise to shut up very soon. But users in the repo, sometimes somebody comes along and shows us like how they do tests, and many times we see this pattern of people saying, "Oh, I don't want even to think about it. I'll just create a test for each a database for each test." Create the schema, do the test, and then tear everything down. And then every single test is going through this entire thing, which is extremely like just the overhead. You just wanted to test one small query, but the overhead around it of the creation of the database, the creation of the schema, the seeding of the data, and then the tear down of all this takes an insane amount of time. And people walk away with the feeling that testing against the database is impossible. It's way too slow. Whereas in fact, the problem is that every single test does so much work. Anyway, that's what I wanted to say.
Yeah, we actually do have some of those tests as well. So we have two different types of the query tests: the assert query ones, the one that we talked about, the efficient ones, and there are some when you are testing some edge cases that are not exactly covered by our framework. Then we have this ad hoc test that does exactly what you just mentioned. They will create a database, they will seed it with data, and then you just perform whatever operations you want. It's basically writing your manual code. There's like very little infrastructure around it just for creating the databases and then tear it down. But yeah, we want to use them as little as possible. Yeah, it's only for those extreme cases where you can't really cover it with the existing framework.
Absolutely. We also, by the way, have tests which exercise writing, like save changes, obviously. And then, as everybody knows, then that becomes problematic. You can't share the database easily because tests running concurrently will start interfering with each other. One test inserts and then another one reads, and it all goes haywire. So in those kinds of tests, we make use of transactions quite a bit. So the test does its updates only inside a transaction, which gets rolled back. And that's a very, very easy technique for maintaining isolation while sharing your database among many, many tests. So you get something that's a bit similar to querying, right? I mean, there's all kinds of tricks around how you do this kind of stuff.
Yeah, I can maybe jump.
I have a question to this. Do we have like a flaky test? And how do we deal with flaky tests?
We don't have that many. We have, I guess we have some Cosmos tests that are flaky, but there is some infrastructure there in the actual product to do the consecutive
retries, right?
Retries, yeah. But apart from that, I think the tests are pretty stable, I would say, right?
Yeah, I've rarely worked on a project that has that consistent green builds. Like we have a very low degree of flakiness. Yep. We also take it very seriously. The moment we have a flaky test, we go and fix it basically, or investigate it, or in some very rare cases, we're going to skip it and get back to it later. But the one fun thing that Maurycy was just saying, so EF comes with resiliency, right? Where if there's an IO network thing, then EF has optional things that basically just retry. And we did notice like very early that in some databases, yeah, we got a bit of flakiness, and then we basically just turned on the retries, and that gives you a layer that takes care of those kinds of errors, right? So if you have the flakiness that comes from stuff like network or database flakiness or whatever you want to call it, that kind of thing, then that goes away immediately by doing this. And in general, it's really quite stable.
And the little bit of that, maybe the flakiness that we used to have in the past more than now, is when we would have queries with non-deterministic ordering. So then sometimes they would work, sometimes they wouldn't, but we are trying to root them out. We have some techniques to kind of try to force people to think about how you order. So then they are kind of getting less and less prevalent, let's say. But yeah,
on that note, like ordering differences, I mean, I personally wouldn't use the word flakiness here, though I totally get like it's also a valid idea. Like in general, if you run the same query on the same database without changing the data, you'll get the same results in general, right? Because why would the results be different, right? There's no random number generator in there, right? However, what we do have a lot, and that's really annoying, is we write a test and we run it on SQL Server and on SQLite, which is what we have in our repo, and it passes and everything's great. But then then I at some point will go. I'm the owner of the Postgres provider. I'll go and run the same test weeks later on Postgres. I'll port everything. I have to sync my provider with EF, and that test will fail because Postgres will have different ordering. And then we find that we actually neglected to specify the ordering in the query, right? Because if you just do a query and you don't say order by, the database is free to do whatever it wants in terms of ordering. And that is a source of many test bugs that we get. Again, I don't think about it exactly as flakiness, but it is a problem. And then every time that happens, I have to go and say to Maurycy, for example, hey, you forgot, an order by. Or the funniest part is when I myself wrote a test on SQL Server, and then I go and sync on the Peachy side, it happens, and then I'm kind of like, this Maurycy, he forgot the order by, and then it turns out I actually wrote that test, and it's really easy to forget, basically. So,
but we are rooting them out one by one, and there are some helper things in the testing front that actually kind of makes it better. But actually,
that's the same for a Firebird. Because, absolutely, because the ordering is slightly different thanks to like collations and stuff, especially if you order on like an unlimited length string, like nvar max in the world. Because in Firebird, if you do unlimited string, it's stored as a blob. And if you order by it with a little bit of simplification, it's not ordering by the content. That would be really, really expensive operation. But each blob in Firebird has like an internal ID. It's like address in the database page. So it orders on this ID. So you will definitely get a different result from like, I don't know, SQL Server. Because it's like a random ID that has no relation to the content of the string whatsoever. So sometimes even if there is the order by and it's sorting on like a blob string, then I need to specifically cast it to a string that's not unlimited to get the correct results, or even change the model in the test.
That's very interesting behavior, I have to say. I've never heard of this.
I think I kind of know what it is. It's the performance optimization, because if you would, maybe for the string blobs, it would make sense to do some ordering, right? You might have like a text content and you want to sort it.
That's the semantics of ordering, right? Like it has
exactly. To be. But for other types of the blobs, you can do the same. And then it's like, okay, we can sort on some random binary data that are completely like, they have no meaning to the user, usually, if it's a binary data. Then we can sort on the ID. And obviously for Firebird, it might be expensive to fetch the blob because it's stored in the database pages, but it's stored as like a B tree. So you have the root page, and if the blob is better than the size of the root page, it's split into like leaf pages. And if it's again bigger than the leaf pages, it's again another level of splitting. So fetching the full blob would mean going into the database file, fetching all these extra database pages, and then doing some sorting. So doing that in memory and efficiently would be really costly. So by default, Firebird is sorting by those IDs. But in recent versions, you can do some casting and everything. So for example, for the string one, it will sort first 32K of characters from the string blob. So it basically fetches like the beginning, and then it sorts it. If there is something at the end, too bad for you.
Understood. Yeah, like a compromise kind of thing.
Yeah.
By the way, I do have one really quick funny story that I don't think you guys are aware of about ordering and tests. So even when we do order by, early when I started doing the provider, the order by was there, and I still got a discrepancy. And I didn't know why my tests were failing. And I was seeing the order by, and the order by was 100% deterministic. It was like order by ID, and the ID, or maybe not ID, but something else that was unique. Let's not use ID here. I see it's unique, and still I was getting like a discrepancy here. And I was like, what's going on? Is Postgres like buggy or something? And it turns out order by is nicely defined and everything. But the question is, what happens with nulls? Like when you order by a field and it has nulls, where do they go? Are they in the beginning, in the middle, in the end, or maybe randomly somewhere? Like nulls are kind of special. And it turns out that, do you guys know where nulls get sorted, by the way?
Well, in Firebird, you can specify nulls first and nulls last as a clause in the ordering. So
And
you
what's the
can choose.
default?
The default is, I think, first.
Maurycy?
I don't know.
I love these little details of IT. Yeah, the tidbits. So .NET orders nulls first. SQL Server orders nulls first as well. I have no idea, obviously, about Firebird. That's a Firebird kind of thing. Postgres orders nulls last. And in fact, and that's why I got my test failures, right? The ordering was different from the expected. And Postgres, like Firebird, has a clause, nulls first, nulls last, that you can add after the order by to actually modify this thing. And you have to be careful because when you even create an index, you can say if the index also orders the nulls first or last, so that when you order by, it can use the index as well, right? Yep. All this has to kind of match up if you want it to work. So I had to go and develop a feature in the Postgres provider to allow specifying nulls first or last. And I did like a hacky thing. I did a thing that's not really exposed as a full-blown user feature because it's mainly for my tests, so that my tests will behave. Basically, I add nulls first to all of the order bys that the tests ever produced, so that things are aligned. Just a funny story.
Shall we jump into code, maybe?
Yes, sure. Let's do it.
Present really quick. So what I was thinking is we can go through a debugging to one of the tests, and then we can show how the sausage is made. Share screen.
Sounds great.
Let me just find my window.
By the way, in the meantime, to fill the void, only 2 people said to send cookies.
I'm saved.
You are saved, yeah.
One
and no cookies for me. I'm disappointed in the audience, you know.
It's almost worth to come in late to see you. So
1 second, let me just try to find the window. Oh, there it is. Share. Can you guys see everything?
Yes. Not yet. Yeah.
Okay. So we can go into one of the tests. Really quick. So these are the, actually, I'm going to show the structure a little bit. So what Shai mentioned, that we have a bunch of Northwind tests. Query. So all these Northwind tests, yeah, they all share the same database. And they do different stuff. But yeah, let's actually do a very basic test. That's a lot of tests, yep. Yeah, so we're going to be covering the assert query framework, the one that is more interesting, kind of does a bunch of things for us. Oops. Let me just, it's still catching up on the build.
While it's building, we can also talk
the faster
about
machine.
whether to use light theme or dark theme.
Of course, dark. Obviously, dark.
Of course, light.
Dark, of course. Yeah. There's no discussion. Okay. So here we are. Here's the assert query test. Can you guys see everything? Yeah.
Yes.
Yep.
So this is a very rudimentary test. It basically just looks at the customers and who are located in London. So let's actually put a breakpoint here and run it. So yeah, a little bit about the structure of those tests. So we have test cases, test classes, and so that's where the test resides. And each of the test classes have a so-called fixture. Fixture contains a bunch of infrastructure and helper methods that we use. And many test classes can use the same fixture, so those will be sharing the same database. And also the tests are layered with the different providers. So this is the bottom layer is for the core test, which we think they should run against any provider. And then on top of that, we have tests that are specific to relational. On top of that, queries tests that are specific to SQL Server, for instance.
Yeah.
And then the same thing goes for the fixtures. But yeah, okay. So let's start here. Let's debug into the tests. So yeah, there's quite a few levels that we need to go through. Okay. This is the meat. So here's the assert query method. This is what is doing all the testing. So let's actually go through. First thing first, we grab a context. So this is we get it from the fixture. So this will be provider specific. We are running the test on SQL Server. So this is going to be a Northwind SQL Server context. Then the second step that we do is there's this set source creator. So if you look at the signature of the method, so these are the queries that we want to test. And they are typed as the iSet source, which is a little interface that we have that just has a set method. So what this allows us to do is we can run the test on the different data providers, let's say, and we do that to help us with the result verification. So this what this line does here is we will create a set source that will wrap the context. So if you look at the default set source, what it does essentially is takes the context, and when you call the set method on it, it will just use the underlying set method on the context. So once you have that, if you run the func that we have provided, which was the original query, you now get a queryable that is actually our EF. You can see the expression. This is entity query root expression, and then there is the where predicate on top. So this is.
So we haven't executed the query yet, just to make sure that people understand.
This is a queryable thing. It has not been executed yet. The execution comes 2 lines down, 3 lines down, and then the next one, the rewrite SQL Server query. So this is an extensibility point that we added, which is basically allows us to modify the expression for all of the tests in that test suite with arbitrary, whatever we want to add there, and then we do that for to get coverage for free. Essentially, that's kind of how we do it. For instance, we can write some collection tests, and then we want to test them on using the split query and the single query. We don't want to duplicate them. We just run them twice. We just created them once, and then we inherit from that test class. We do a little snippet here that would rewrite the query to inject a little split query, and then we basically get the test for free. But this is a very simple case. There's no rewriting going on, so the query is exactly as it was. And now there's the ordering setting verifier. So this is kind of another thing that helps us with the ordering problem. And one thing that we learned is that if you have a lot of tests, you will make a lot of mistakes writing them. So if you can find an invariant, something that should be basically applying to all the tests, just code it in. So this what this thing here does is it checks that the query that you provided us, it has been ordered. It has ordered enumerable ordered queryable, and if so, then we want you to think about and we want you to assert that the order that you provided is deterministic. So assert order. This means that we think that this order should be deterministic, and then if it's not, then we will throw. So that kind of helps with that. And we also have another similar thing a bit lower at the very end, is we verify that the test that we do returns some results. We used to have a problem in the past where we would have some sophisticated projection, but the projection was not returning anything. So we would actually not test anything at all. So now what we do is we require at least one result unless you explicitly tell us that the result should be empty. You need to be very deliberate about it. So those little things kind of like avoid those simple errors that you are bound to make. So now we've done this.
To make sure that this is clear to people, like if for example, this test with the where London, let's say it returned nothing because we didn't put London, we put something else that doesn't exist in the database. If the query returns nothing, then we don't know if the where is actually working, right? Mm-hmm. We don't know if it returns nothing because the where is working and filtered everything, or maybe there is no where. Maybe we completely failed to translate it to SQL, right? In order to be sure that the where is actually doing something, yes, you need to have at least one row coming back, and this is the idea there.
Yeah, and then sometimes the projection, like what we usually mentioned in the beginning, we have a shaper that has a complex stuff going on, and we want to test that, and that you can test that without results. Okay, so now what we can do is we can execute the query. So this actually runs against the database really quick. And now we have our Londoners. Yep, there's 6 of them. And now where the actual value of that framework comes is we now want to verify that the results are correct. And we want to do it in an automated way, ideally. We don't want you to write those asserts every time. So the way that we do it normally is you would create a thing called Oracle, which is a thing that you ask it a question and it always knows the right answer. So it would be great to have it. And the way that we implemented it here is we have the expected data that we created. And let's see. So this is Northwind data. Let's actually look at this. Northwind data. So this is a set source as well. And it's basically a replication of the Northwind database in memory. So if you look, it has all of the sets. And then you have customers. If you go in, all of them, we've painstakingly copied them over. So we have representation of Northwind in memory that we can actually run our queries against. So now if we run the expected query against that set source, we can get a queryable. This is also has not been executed yet. It's a iQueryable. And you see that instead of the entity query root, we actually have an array of customers here. And then after that, there is...
Maurycy, we don't see your pop-ups because you shared only the window. So that's how it is, unfortunately. But I mean, it's okay. Just be aware that we're not seeing your pop-ups.
I see. Okay. Okay.
I think it's fine.
So you can't see any... you can't see anything that I hover over. I see.
Yes.
Unfortunately not.
I see.
Sorry, we should have probably told you this before.
It is what it is. But yeah, so we the next step that we do is rewrite the query. So there is a discrepancy between link to objects and link to and EF queries. One of the big changes that we do in EF is we provide null propagation. So if you have if you're accessing a property of a null object, EF will return you null, but the link to objects will just throw nullref exception. So what we want to do is we want to compensate for those changes. And the way we do is I can't show you, unfortunately, in this rewrite query, we actually modify the predicate so that it kind of has the custom-made
null checks and stuff.
And then this actually can get pretty complicated because let's say in here there's a city, it's a string, but if it was an int, then the type of that expression would change. And if you compare it to London here, if you compare it to, let's say, 7, then you have a discrepancy of types because on one side you have int, nullable int, and on the other side you have int. So we need to make the changes and propagate the nullability everywhere. So there's quite a sophisticated thing going on over there. The other thing that we do is...
I would like to point out that the viewers can see one kind of overarching story. Our team is really good in rewriting something. We are rewriting link queries into SQL. We are rewriting our test queries into something else. We are really good, basically. You give us something and you think we would translate it to SQL, but in the meantime, we go through like 15 different layers of rewriting. Yeah. So it actually does what it should be doing. And it's not really straightforward. And we are like fiddling with reflection and expression trees and everything. And that's what we do basically, right? The EF is like
is the best design
tree, reflection fiddler.
Yep. But yeah, so now that we have patched the expected query, now we can run it and we will get presumably the same results as before. And we have 6 results as well. You can't see it, but yeah. And then the last step that we do is we compare those results together. So the way that we do it in here is we can do it 2 ways. So one, we can just fetch the first result of the real query and then look for it in the expected ones, but that's slow. What we do instead is we order both of those in a deterministic way, and then we can just compare one by one. That's quicker. And then the framework, what it does, it provides predefined sorters and asserters for the entities that are being used in the query. So let me actually show you. This would be in the where is it? Okay, 1 sec. So this is the fixture. That's where the sorters asserters are living. And normally you don't have to worry about it. If you would create a new infrastructure using a kind of completely new model, you would have to add this. And this is a significant overhead that you do, but for the most part, you can just reuse what we have. So these are all the entity sorters for all the entities that are being used in the model. They just order by a key. And then there are asserters for every single one as well, which is just go through all the properties and compare them so we make sure that all the data is right. And once we have, we get those sorters automatically. And then the final step is asserting the results. So first of all, the count has to match. And then there's a little check that we actually can do. That if you have a sorter, you can use a sorter, otherwise you can't. And then we just order by them on the client, so it's fast. You don't have to go to the database, and then we can just compare them all one by one. And they all pass, perfect. And the final step is verifying the SQL. So then I mentioned in the beginning, there's a bit overhead with managing the baselines. We actually have constant discussions whether it's worth it or not. We think it's worth it to have those verifying the SQL, but there's a little neat trick that you can do this is for probably the most useful thing for people who want to contribute to the project. There is in assert baseline, there is this little EF test rewrite baselines. So this is an environmental variable. If you set it in and then run the queries, then all of the baselines, the test will fail, but the baselines will be rewritten to the new value. So this way you don't have to kind of do all the manual labor, copy them and fix them up. It will be done for you automatically. Of course, you have to look that the baselines are still correct, and we will also verify that, but at least you don't have to do the busy work. So I don't know if we have time, I can simulate a little bit of how that works. I have already preset the how are you on time, guys?
Yeah, what do you think, Jiri? I do want to, because you've gone through a ton of stuff. I just want to make sure everybody is still on the same page with us. So the first thing that's really important, we've kind of glossed over it a bit. It's really an amazing thing in my opinion. EF uses link, right, to express the queries. And in our testing, we take advantage of the fact that you can use the same link query more or less against the database. That's what EF does, the translation to SQL, and also against in-memory. That basically allows us to take the same expression where the thing is London, and to run it once against SQL Server or Postgres, and once against this in-memory collection that Maurycy was showing. And the results that come back, we can just compare to see that they match. That's the oracle that Maurycy was mentioning. It's not the usual case. This is actually very unique that we have a thing like this, right? Usually, when you write a test, you need to do the expected stuff yourself, right? You do assert that you get this, assert that you get that. That's like how you write tests. In our query test, we don't actually do this in the normal case. We just run the same thing, the same query against both things and compare the results automatically. And most of the machinery that you saw here was around facilitating that comparison, right? Around questions of ordering and questions of, slight discrepancies between how these queries get evaluated on SQL Server versus how they get evaluated in memory. So we kind of smooth all that out, and we end up in a place where if we want to do a new test on a new kind of expression, all we have to do is define the test and call a single assert query, like very minimal, and express the query, and you were done. And we get amazing coverage. It's also usable directly for any database that we support. So Postgres will get the exact same test the next time it takes a dependency on the new library. So it's really, really a super cool thing here that we have, in my opinion, at least. Like, we've invested a ton in making this a very robust kind of test infrastructure where things are layered properly. Like Maurycy was saying, like, you don't have to write it once for SQL Server and once for Postgres. You just write it once in an abstract way as a link query, and then it gets evaluated on both. There's a whole lot of machinery here to make all this kind of work nicely.
Yeah, all that work definitely evidence by now, I would say.
I want to point one small thing out. You said that we are testing against the database and then in memory. that does not mean that we are using the in-memory provider.
Right. Yeah.
It's just that the data are sitting in memory and we are using link to objects.
Exactly.
It has nothing to do with the in-memory provider, and we do
Which
not.
we hate. We hate
Which
the
we-
in-memory
exactly,
provider.
yeah.
That's
Exactly.
why there was a suggestion in the beginning to try testing against the actual SQL Server if you can. Don't use the in-memory provider if you can avoid it.
Absolutely. Yeah. We use enumerable. Like you said, we use link to objects, which is evaluating it in the memory, right? Like, but not using the in-memory provider. Very good point.
Yeah. Okay, so let me do it real quick. So this is going to be, I'm going to simulate an improvement in the translation of something. So this is a SQL query generator. It's the final step when we are producing the SQL that we send to the database. So I'm just going to hack a little bit. So we are going to process SQL constants. And if a SQL constant type is int, we will just, there's a command there, append, +0. That will not change results, but it will change the baselines. So now I have already I have set the variables beforehand, and now if you run some of the tests, they should fail. Let's just run a few.
This is super cool.
Yeah, it's definitely saves a lot of time. It has to build because there was some change, so fast machine.
Yeah, otherwise, like I remember this, like if you don't have this and you do a change, now you have to go through, I don't know how many test failures and update your SQL. It's a nightmare.
So yeah, so here's one of the tests that failed. Did I not set the thing? Oh no.
I mean, it failed, so.
It failed, but then we should see the updated baseline.
Maybe you don't have the
variable. I think I didn't.
Variable, yeah.
Yeah, okay.
Too bad. We can believe you.
What we can do is we can do a really quick hack. Assert query.
Yeah, comment out the check for the environment variable.
Exactly, that's what I'm gonna do.
Nice, great minds think alike. If we're hacking, hack all the way, man.
Is that where this is? Not assert baseline. It's in the bottom here.
There we go.
Oh, wait,
no, you passed it.
I missed it.
Yeah, it's like 100.
Here it is.
There it is.
100. Yeah.
Okay.
Try again.
And then we can try again.
Isn't this what we do every day? Hacking stuff?
Pretty much.
Putting random stuff together?
Absolutely, man.
Putting random strings together and hoping that it's a valid SQL.
So it will fail. It failed again, but you can see there is a 0 here now. So there's the baseline has been updated. And if you run it again, it will work. Magic. Of course, you need to still look at the baselines, but yeah, the hard part, the manual labor, is done for you automatically. Let's see.
2 comments on this mechanism. So first of all, like my flow, if I work on the query pipeline, I do this thing, I run the tests with this environment variable, and then I do git diff. And that's how I see the effects of my change, right? I actually use diff to see the, what I did to EF. I see tons of tests and suddenly, there's something that's replaced by something else. It's super cool.
I do the same, yeah.
You do the same, right? Like it's really, really useful to view, like you do some change in the SQL pipeline and in the query pipeline, and this is how you see the results. And that's given that we have so many tests, you suddenly see like the best part of my job maybe is if I do some sort of optimization, like somewhere in the query pipeline, and then I run the tests and I see, or sometimes suddenly I see the SQL changing, like in the diff, completely different. And sometimes it changes in very unpredictable ways. Maybe the small optimization that I did here actually unlocked another optimization. That's how these things work. And suddenly everything got compressed. Something that was super big and inefficient before is now like very tight and cool. And I look at the actual, thing, and it's like, it's a moment of bliss. Like it's the best thing that can happen, right?
And this is the major value of why we actually verify the SQLs. So you actually can have when you look at a change, you can see instantly, look at the SQL, and you can kind of grok what's going on. And the other side of that is sometimes you have a change, and then you see that the baseline changes in somewhere completely different, but it's actually getting worse. And
Right.
this is where you caught a bug, what you would have normally not caught if you haven't had it. So this is actually the
Absolutely.
main value. And even though there is some maintenance and all the busy work, I think that this is super valuable for us.
Indeed.
Yeah. So that's
Yeah,
basically what I had.
By the way, this component works by using Roslyn. It actually uses the compiler, Roslyn itself, to parse the source code. So it gets the exception. The exception, the diagnostic, the exception actually tells you where the exception was thrown, line number and column, and file name. So it actually opens that file name, parses it via Roslyn, finds the place, and does the string rewriting in place. Like that's lit. It actually uses Roslyn, which is another super cool example of how having a compiler as a service, like Roslyn, is like as a package, is a super cool concept that we have in .NET. Like if we were in another programming language, we would simply not be able to do it in the same way. We would have to do some scripting around it in some way externally, but this can be completely integrated into the whole thing. Also, sorry, go ahead.
No, I'm done.
Okay, but I'll just note that I was discussing at some point with some runtime people, like people who work on the JIT, and they have a bit of a similar story there, right? Like they also basically produce something. We produce SQL, they produce code, right? Like binary. And at some point, they also have tests which actually assert on the binary, like actual assembly that comes out of the JIT. And then maybe they do a change, and suddenly across many different tests, they have a change there, and things suddenly modify. So EF is, in this sense, it really is a bit of a compiler, right? Or maybe the correct term is a transpiler. It transpiles from one language to another instead of compiling from something like a higher level language to a lower level language. But the concerns are kind of the same. We are both translators, and therefore in your testing, you want to test a huge number of scenarios, translations, and you want to make sure that the output is what you expect it to be, and you want to especially be aware of unintended changes that have happened to an output in some test somewhere, right? So we commit the actual outputs as baselines into the source code. They're part of the test code. And we have machinery for making bulk updates across these things because something changed. That's like part of the lifetime of a project like this. That's part of the stuff we have to do, basically.
Awesome. So we are on time. So I will go around and give 1 minute. That's especially for you, Shai. 1 minute only for last thought. And then we will wrap up. So, Maurycy,
start with somebody else.
Go first. You are the guest.
I didn't know that there was something like that. I'm not sure what to talk about.
Well, you can vote, and you have 3 votes, so that Shai needs to send the cookies.
Okay, fair enough.
Okay, so we have 2 votes from the audience, 3 from Maurycy. That's 5.
You're still trying to get to the
beginning. Oh, okay. Sounds good.
Anyway, Shai, some last thoughts?
Yeah, I mean, this community stand-up was more about EF internals, right? It's about how we do our testing. It's not about how users of EF do testing. That's a different subject. It's probably more relevant to more people if we talked about how you guys should write your tests. But we've already talked about this a little bit, and we probably will talk about it again, like best practices for writing tests in your application. But every now and then, I personally think it's great to dive into EF's problems, like how we as developers of EF, like what kind of stuff we have to deal with and the complexity. So, and it relates, the 2 subjects are obviously very related, right? We're testing database related stuff. And EF is such an interesting beast and quite complicated, of course. And you learn so much by just understanding how even we test EF core things, right? So I always look at this and I find it fascinating, like the point where we got to.
Awesome. So we are done. Thanks for watching. If you're watching live, definitely another thanks. If you're watching the recording, you can go to GitHub and comment on some issues and check the pull request and check the tests. Next month, we have another special guest. It's not going to be our faces. It's going to be special guest. We will be talking about Azure, SQL, and the vector search. At least that's the plan. Obviously, plans can change, but it is lined up. I already have the guest ready and everything. So if you are interested in Azure SQL and SQL Server and vector search, and definitely tune in. Next month, I will be publishing the schedule and everything, the live stream soon. With that, thanks for watching and see you next month.